Hello, bird watchers. Miss Sorensen here with adding vectors. All right, let's take a look at what this box has to say. You might want to pause the video and get those rules down. Basically what this is saying is if you have two vectors, okay, one has horizontal component u1 or u sub 1 and has a vertical component of u sub 2. Then we have another vector, we're going to call it vector v, and that has a horizontal component of v sub 1 and a vertical component of v sub 2. If we are to add these vectors, all you do is add the horizontal components. So what I mean by that is you would add this horizontal component to that one. Then to get your vertical component, you would just add u2 or u sub 2 with v sub 2. And it's the same exact thing for the other operations. It's really very intuitive. If you're going to, subtract, you're going to do u sub 1 minus v sub 1, and then you would do u sub 2 minus v sub 2. You have to go in the correct order, right? If I'm doing u first and then minus v, I have to start with my u vector over here. Now, if I asked you to do scalar multiplication, that's a fancy way of saying multiplying by a constant. All you would do is just, if I'm going to take my u vector and I'm going to multiply it by a number, let's say 4, I would just do 4 times this and then 4 times that. It's essentially the distributive property. And then if I'm going to put a negative out in front, that's really multiplying everything by -1. You would just negate the other two. I think that's the easier part of adding vectors. What we do have to do is kind of remember how to even find out what the horizontal and vertical components are of the vector. So here we have to find out what the horizontal and vertical components are of vector AB. And to do that, we have to look at from A to B. How far is it to get from -1 to 3? Well, it's 4. How far is it to get from 0 to 1? Well, that's going to be 1. So I just found out the horizontal and the vertical components of vector AB. Now I'm going to do the same thing with CD. And so I'm going to go, how far away is 2 to -3? Well, to get from 2 to -3, I'd actually have to subtract 5. How do I get from -4 to -1? Well, you can draw a number line if you'd like, but to get from -4 to -1, you would add 3. So personally, I think that's the hardest part, although it's not too bad. We just found what vector CD was in terms of its horizontal and vertical components. And now we need to add, right? This says add the two things. So what I'm going to do is do 4 plus -5, which is a -1, and then 1 plus 3, which is 4. And that's my answer. All right, let's do the next one. So we're going to do vector BC, and first, before we even subtract, I have to find out what the horizontal and vertical components are of BC. Well, how do I get from 3 to 2? I subtract 1. How do I get from 1 to -4? Oh, I subtract 5. So that's my BC right there. Now I want to find what DA is. And remember, I'm going to be subtracting them. So my DA, I'm going to have to erase what I have here. I'm going from D to A. So how do I get from -3 to -1? Well, I add 2. How do I get from -1 to 0? Oh, I add 1. And now, since this is a subtraction problem and I have my vector DA now, I can do this. So I'm going to have to do -1 minus 2. -1 minus 2 is a -3. And then I have -5 minus 1. And that's going to give me a -6. And that's going to be my solution. All right, the next one is -2 times AC. So that's going to be -2. And my AC, I have to get my horizontal and vertical components, so let's get that. So from A to C, how do I get from -1 to 2? I would add 3. And then how would I get from 0 to -4? Well, I would subtract 4. And just like I said with distributed property, you're going to multiply through. So -2 times 3 is a -6. And -2 times -4 is an 8. Sweet. That's our answer. So now is when I want to talk to you about unit vectors. So three-dimensional, we're not going to cover this in terms of testing, but it is interesting to know, especially if you go into engineering or science or physics, any sort of thing that deals with vectors. The world is in 3D, so we have to recognize this. And the best way to do this is think of this as a wall where this is the ground, and then this is where two walls come together, and there's kind of like that edge of the wall, that 90-degree angle. And so that would be your X, Y, and your Z plane. And you should think about, just kind of the corner of a wall, if you will. So our three unit vectors in three-dimensional would be the coordinate 1, 0, 0, which is located right here. And then vector J would be here, and vector K would be here. So just a heads up, if you didn't understand that, it's not a huge deal. I'm not testing you on it. We do need to know the two-dimensional version, though. So this is just a normal XY plane. And if you think about the horizontal component being 1 and the vertical being 0, then I would be located right here, right? That's our unit vector. It's a length of 1, and it's on the x-axis. Vector J is this one right here. It's basically going left, right, 0, and then up 1. So we're just up 1. And we've got a magnitude or a length of 1. I would absolutely get this down. We're going to need that for our next steps. All right. So these questions are looking a little bit more like the ones on your final, although it's going to get even harder than these two, and not significantly though. So what if we were to add I and J? Well, let's use this down here. We know I is 1, 0, and we know J is 0, 1. So we add those. So I'm going to add 1 plus 0 is 1. And then 0 plus 1 is going to give me a 1. So that's my answer to that one. All right, this next one's getting a little bit trickier. So this says if V is 2I plus J and W is 3I minus 2J, what is V plus W? So it's asking us to add these complicated vectors, and then we should turn it into the horizontal and vertical components. So here's this process I like to do. I like to put them right on top of each other. I like to say vector V is 2I plus J, and W is equal to 3I minus 2J. And just as a reminder, we're adding these two things. And so I'm just going to straight out put a plus here and add straight down. So 3I plus 5I gives me 5I. And then a J vector minus 2J gives me a minus J. Well, now I need to go back and kind of substitute in, if you will. So this 5I, instead of writing I, I'm going to write the 1, 0, which if you're forgetting where that comes from, you're going to look at this over here. And then I'm going to have minus, and then I'm going to have my J, which is going to be 0, 1. So let's go ahead and kind of do distributed property here. We're going to have 5, 0, and then this is going to be minus 0, -1. Okay, and that should change to a plus actually, right? Because I've already distributed that negative in. And so now I have 5 plus a 0, which is 5. And then I have 0 plus a -1. And if you didn't even have to do that, you could have said, oh, I'm subtracting a 1, if that makes sense. So, so this is going to be 0 minus 1, which is a -1. So there's our answer. Oop, I screwed that up, didn't I? Hold on one second. Nope, it looks good. Don't know why I was second guessing myself. So there's our answer there. All right, let's move on. Okay, find the following. If we've got vector V is 3I minus J and W equals 2I minus J, find the magnitude of the vector. You might want to put a star in your notes, right? This is going to be hint, hint, really important. So interestingly here, it's actually asking us to do 2v minus 4w. So before I just wrote down the v and the w below, but right now I'm actually going to write down what is a 2v equal to. Well, 2v is going to be double everything here. So that's going to give me a 6i minus 2j. Okay, and then if I'm asking for 4w, okay, the 4w is going to be 4 times everything right here. So that's going to give me an 8i minus a 4j. Okay. Now, it's asking us to do 2v minus 4w. So really, this is asking us to do, here we are right here. If you want, you could kind of convert these into the horizontal and vertical components first, but I don't think that's the best idea. So if I want 2v, I know 2v is 6i minus 2j, and then I'm minusing my 4w, which I'm going to put in parentheses. That's going to be an 8i minus 4j. So I'm going to distribute that negative through. That's going to give me a 6i minus 2j minus 8i plus 4j. Okay, now I have to combine my like terms. A 6i and a negative 8i gives me a negative 2i. And then a negative 2j and a 4j is going to give me a 2j. Okay, and then I'm going to go ahead and substitute these values up here. So a minus 2 times my I, which is going to be, let's see, that's 1, 0. And then plus 2j is going to be 0, 1. So that's going to give me minus 2, 0, plus 0, 2. So all I've done so far here is just distribute through. So then this is going to give me minus 2, 2. Okay, so now we have to find the magnitude, and remember that formula is right here. Okay, so we just have to find the square root of minus 2 squared plus 2 squared, which is going to give me the square root of 4 plus 4, which gives me the square root of 8, which I can rewrite as square root of 4 times the square root of 2. And that becomes 2 root 2. Sweet. I think we need to do another one, don't you? All right, here we go. If v equals 2i plus j and w equals 5i plus 4j, find the magnitude of 3v minus 5w. So the first trick here is to find what 3v is, and I'm just going to basically multiply all this by 3, which gives me 6i plus 3j. Then I want to find 5w, and don't forget about the negative, but we'll deal with that after. So our 5w is going to be 5 times all of this, which is going to give me 25i, and then 20j. So I basically just took everything here and multiplied it by 5. So now I'm actually asking for 3v minus 5w. So that's going to be equal to my 3v, which I'm going to rewrite this. So that's going to be 6i plus 3j. Now I have to put minus, and now I have to put parentheses because my 5w, I'm going to substitute in for that. And that's going to be this. So don't forget your parentheses. So it's going to be 25i plus 20j. So now I'm going to distribute that through, and I'm given 6i plus 3j, just dropping that down, minus 25i minus 20j. Okay, now combining like terms, I have to combine my 6i and my minus 25i, which gives me negative 19i. And then 3j and minus 20j is obviously negative 17j. And now I need to substitute back in. This is going to be negative 19 times 1, 0. And then we're going to have minus 17 times 0, 1. And I'm going to distribute this through. and this is going to give me negative 19, 0, and then I'm going to have, let's see, what am I going to have here? I'm going to put a plus because it's going to be 0 and then negative 17. Just remember, whenever we have a subtraction here or a minus, we can just basically write it as a plus and then a minus minus for both of them. Okay, now I'm going to add both of these up. So a negative 19 and a 0 is going to give me a negative 19. And then a 0 and a minus 17, adding those, I get a negative 17. And now I'm going to go ahead and I'm going to do the Pythagorean theorem because it's actually asking me for the magnitude. It's going to be negative 19 squared plus negative 17 squared. And I'm doing that in my calculator. I get the square root of 650. You can either leave it like that if you'd like, or you can write it as 25.5. There we go. I think I want to do one more. Hope you do too. You might want to just pause this video, try this on your own, and make sure you're getting the same answers. So let's do 2v plus 4w. So my 2v is going to end up being double this. So that's going to be a 4i minus 8j. And then I'm going to do this times 4 because of that right there. So that's going to give me 4w is going to give me 24i and then minus 8j. Okay, and now I have to add these two things, which is nice because before we had subtraction. Oh no. My computer just said it was low on batteries. Sorry about that. So I've got my 4, let's see, where was I at? Sorry. I'm adding my 2v plus my 4w. So that's going to be 4i minus 8j. And then I'm going to add, and if I had minus here, I'd have parentheses, and I'm going to include them here anyway, but you don't really need them. So it's going 24i minus 8j. So now I've got 4i minus 8j plus 24i, and then this is going to be minus 8j. So that's going to give me, well, what have I got here? I've got a 4i and a 24i, which gives me 28i. And then a minus 8j and a minus 8j gives me a minus 16j. So this 28 is going to be times 1, 0. And this minus 16 is going to be times 0, 1. And so this is going to be the vector 28, 0. And remember, if there's a negative in front, you're just going to make it a plus and then make it the opposite, right? And I'm also multiplying that 16 through. All right, and then 28 plus 0 gives me 28, and then 0 minus 16 gives me negative 16. I'm going to throw that into Pythagorean theorem. Okay, and then that's going to give me a big number. I'm just going to rewrite it as 32.25. You can plug that. Don't forget your parentheses or else you're going to get that incorrect answer. All right, folks, that's it for this adding vectors, especially unit vectors. Thanks for watching.